Hello everyone. Today's topic is based on Beckmann rearrangement and Beckmann fragmentation. If you look at the scheme, there is a carbonyl compound, the reaction with hydroxyl amine and PCl5. What would be the expected compound? The question was asked in GATE 2022. Here four different options are there. Among four, A would be the right choice. Now the question is the compound A, whether it is Beckmann rearrangement compound or Beckmann fragmentation. For understanding this concept, let us go into the details. Beckmann rearrangement in case of cyclic ketones. For example, here I took cyclohexanone, the reaction with hydroxylamine in presence of acidic catalyst, that is H plus, it gives the corresponding 7-membered lactam. Since it is a cyclized form, we can call it lactam. If it is uncyclized, it will end up with the corresponding amide. This lactam also named as caprolactam. This is the most important the compound. It can be utilized as a starting material in the synthesis of nylon polymer. Well, come to the mechanism. Now the cyclohexanone, after treatment with hydroxylamine, it formed a corresponding oxide. Now OH, it can take H from the PTSA, then it forms OH2 plus, then it will act as a leaving group. The leaving group opposite or a trans, the bond it will migrates to the nitrogen, then water it eliminates or water it leaves. Then it forms the corresponding carbocation and the cation will be trapped by water. Now here the para-toluene sulfonate, it picks the proton and it forms the corresponding imino or iminoalcohol. So after tautomerization, it gives the corresponding 7-membered lactam. So the main difference, whenever we used the cyclized ketones, the mechanism it goes through carbocation. There is a slight difference when we use acyclic ketones. Here we took a benzophenone, but in such cases, so whenever we take acyclic ketones, the mechanism it goes through linear nitrilium ion. Why it is called linear nitrilium ion? So here the nitrogen lone pair it pushes towards the double bond, then it attains the triple bond character, then phenyl it migrates to the nitrogen. Since it attains the triple bond, the structure will be the linear form. Then now it will be attacked by water. So it does not matter whether it is a cyclic ketones or acyclic ketones, outcome will be the same. But mechanism wise, whenever we take cyclic ketones, it will go through carbocation, whereas acyclic ketones case, it will go through nitrilium ion. That is the main difference. Okay. The next important point, which is for activating leaving group, here we use it H plus. Not only H plus, other activating groups can be utilized, such as PCl5, thionyl chloride, acetyl chloride, and tosyl chloride. Okay, then we'll move on to the next topic. Here, difference in Beckmann rearrangement in presence of Lewis acid and Bronsted acid with unsymmetrical ketones. The previous case we discussed about the symmetrical, both in case of cyclic ketones and acyclic ketones. But in this case, we are going to discuss unsymmetrical ketones, and but here the catalyst is two different forms. One is Lewis acid and another one is the Bronsted acid. If we use the Lewis acid, the methyl group which is oriented trans to the leaving group or anti to the leaving group. So whenever we use a Lewis acid, so here we used alumina, nothing but Al2O3, we used as a Lewis acid. The methyl groups migrates to the nitrogen, then the O total it leaves, then we'll get the product A. But in case when we use Bronsted acid, so instead of methyl migration here, in such cases, whenever we use Bronsted acid, the more substituted will be the migrating group rather than the less substituted. But in this case, the more substituted it is cis to the leaving group, but whereas less substituted trans to the leaving group. In such case, it interconverts. So interconversion is faster than the rearrangement. Then it interconverts. The more substituted migrating group, it will be orients trans to the leaving group. Then more substituted group migrates to the nitrogen and gives the corresponding compound, which is the product B. So for example, if you take substituted cyclic ketones, so in presence of hydroxylamine and H plus, obviously the NH insertion takes place towards the more substituted, right? The same thing, even if you know the Bayer-Villiger oxidation, there also oxygen insertion takes place next to the more substituted. The similar way in Beckmann rearrangement as well. The another case. Now here we discuss when now the substituted or more substituted is there, that is a favorable for the migration. But whereas the substitution, if it is tertiary, so in this case that is a tertiary, but in this case it won't follow the regular Beckmann rearrangement rule. So here this is the tertiary substituted one, and right side is less substituted after treatment with hydroxylamine. The OH is activated by using acetyl chloride. In such case, the compound A, which is a regular Beckmann rearrangement product, but we don't get it. Instead of that, the product B is favorable. So if you go through the mechanism, we can clearly understand why instead of a product A, we are getting the product B. Here I gave the numbering 1, 2, 3, 4, 5, 6, 7, 8. So after treatment with hydroxylamine and acetyl chloride, the corresponding oxime, OH10 oxime. We already know that the tertiary carbocation is more stable. Why it is more stable? Because of the inductive effect. The tertiary is more stable. Here, instead of migrating to the nitrogen, here the what is the bond 1 to 5. The bond instead of migrating to nitrogen, here what it happens, it will fragment. The next picture you can see, it will fragment, and whatever the name of the carbon 5, now it became the tertiary carbocation. tertiary butyl carbocation, which is a stable. Now after that it will undergo for, now this both the structures both are same. For understanding it is easier, then it will undergo for the elimination, then we'll get the corresponding product B. But so based on this concept, whenever there is a tertiary butyl substitution is there, the compound which will not undergo for regular Beckmann rearrangement, rather than it prefers the fragmentation. Now that is the question in the first slides. I asked about whether it is going through Beckmann or Beckmann fragmentation compound. Now I think based on this concept we can clearly understand in which direction it is going. Now for example, here I took one example, the same example which I took it in the previous one. Here also the tertiary substitution. So obviously it will go to the Beckmann fragmentation product. The another example here, the substituted, the next to the site oxime there is a flanked by phenyl ring. So this is the more substituted case. So obviously we will get a seven-membered lactam which is flanked by the phenyl group. So here the reaction it is went through the Beckmann rearrangement product. I think hope you guys understood. Thank you everyone.